In this video, we're going to take a deeper look at how we can model data for our applications. Now, this is a little bit challenging. There's some art versus science in this topic, but oftentimes we find that the way that we store our data is very different than the way we work with it in our application. One thing to note is that when we store our objects or when we store our data, that doesn't always exactly correspond to the data that we use in our application. So in your application, you may have very complex objects. You may have objects built for the purpose of iterating through things or calculations, different purposes like that. Whereas in storage, they really only have one purpose, which is to store them. So generally, you find that when you store your objects or you store your data, that's built in a way that makes it simple to manage in the database layer or in the data storage layer. So when you're thinking about this, it's usually good to think about how you're going to use the objects in your application versus how you're going to use the objects in storage. Application objects tend to be somewhat complex, hierarchical. They may contain complex structures. There's often data structures embedded in them. Sometimes they may be data structures in and of themselves. So, oftentimes application objects have behaviors. They have a lot of different complexity that you don't need to think about in storage. Storage tends to be more basic. Storage tends to be just entities and attributes. So whether you're working with a database table or you're working with a more complex object storage system, typically you think about the entity, that would be more like the row or the table, like one individual object would be one row in your table, or one entity in Datastore would be, just one object that you're storing in Datastore, one of these entity objects, and then the attributes, the properties of those objects that you might need to persist. So if you think about things in that way, typically if you can think of a single object with several properties, that's a good way to think about how you often design your data modeling. So one example might be if you were building a forum site, your forum may have a title, it may have several messages that are part of that forum. Each one of those is going to have its own properties. Then there may be a user which may have its own properties. And often if you were to retrieve these and you were to interact with them in your application, show them, render them, etc., it might look something like what you see on the left. Whereas if you are storing those, your forum may be one particular entity of its own, and then each one of the messages might be associated with that forum. So forum and message would be two separate storage objects, but message might refer to the forum. So you can see, the forum ID is that fifth property there after time, text, and title for the message object. And then you would have a user ID, which would have its own set of properties. And this gives us a couple advantages. One is that we can store these in a pretty basic, simple way. But the other nice advantage is that now we can use these different objects in different places as necessary. User may not be only associated with forum posts. There may be user profile pages. There may be a whole list of users. There's a whole variety of ways you could use user, including authentication, that you don't actually have to think about. You don't want to have that part of the forum itself. You probably want to have that as its own individual entity so that can be reused more effectively. So in a relational database management system, you typically have tables, you have primary keys and foreign keys, you have association tables. The idea is that you would have a table that would represent an entity. The records would represent each individual instances of those entities. Primary keys would be how you identify each of those entities, and foreign keys would be how you refer to other entities that may be part of that or may be related to that particular entity. In a hierarchical format, though, more like what you see in Datastore, you're going to have more has-a relationships. So you can have ancestor entities, you can have descendant entities, and one of the things that I always find is that when you talk about that in a programming context, a lot of people think you're talking about inheritance, but in this particular case, this is more of a has-a relationship. So if we go back to the forum, you may have a forum as a parent entity, and then a message as a descendant entity. And then you wouldn't actually have to associate those directly. That would be automatic as part of the way you're storing data. So the forum would be your ancestor, and the messages in that forum would be descendants. The other thing that you have in the data store are key properties. Key properties allow you to sort of work similar to what you might have with a foreign key. So each one of these entities is like a record in a database, and these records have keys, and we have that key property, but we can also have a foreign key, which would allow us to have a key property as well. So, there are a lot of different kinds of data that you can use, or different types of data that you can store in the data store. One of those is a key property. So if you can store a key, then you can very easily retrieve and access any entities that are referenced by that particular key. And again, instead of using key properties to associate objects, you can use ancestors and descendant entities, so that when you create each one of these, the parent can be specified, and that will allow you to automatically associate these in a way that probably doesn't require you to manage your own key relationships. Each entity would then have a key. Its parent would be part of that key, and then you could very easily access that parent. You could also access the descendants in that way, in a pretty straightforward way. Now you can use lists and you can use dicts in Cloud Datastore, but they might be difficult to manage. Sometimes you may want a list, but really what you need is a separate entity on its own, and maybe those need to be associated, or maybe that needs to be more of an ancestor or descendant relationship. But generally, simple, lists, when you have simple types, simple data types, that can be effective. But anything that's more complex than just a simple, int or string or float, probably would be better managed as completely separate entities. That way, you can use descendants or not, but generally speaking, having these complex object hierarchies within your data store, it's not impossible, and you can definitely make it work, but it might become a challenge to manage that. So hopefully this will give you a little bit of understanding on how we might represent our objects in the data store a little differently than what we might use in the application. And hopefully that will give you some understanding on how you might take a look at ancestors or descendants. There's also more documentation within these slides if you want to click it through and see a little bit more about descendant and ancestor entities in the Cloud Data Store. Thank you for watching.